G'day everyone, how you going there? This is a bit of a different situation for me. It's the 30th of March and I have no students in this classroom, so I'm just talking to you now. Look at that, you're special. This is a bit of teaching that I did a while ago, and I never did a video on it, so I thought I'll just put a little bit of a summary video here. We're in the function section of our specialist course. This is the first part of the dot points that read. They talk about different types of functions. So let's just run through them. We've got one-to-one functions, which what that means is one x value will only give me one y value. Or a different way to put it is that for every point on the domain, there is one point in the range. So a one-to-one function, the simplest one to look at is a linear equation, because no matter which x value I pick, I'm only going to get one y value. It doesn't matter where I pick that value, I'm only going to get one y value. And you know that these linear equations head on infinitely either way. So of course, it doesn't matter. The whole domain is sorted and therefore the whole range is sorted. So look, let's call this y equals x plus 2. That'd be a fair example of a one-to-one function. Many to one. Now this is meaning that many x values can give you one y value. And the easiest way to visualize this is a quadratic, because look, I could pick that x value there and I would get that y value. And similarly, you can already see about that x value there will give me the same y value. Okay? So any quadratic is going to come up with this sort of thing, and there's other ones as well that will come up like this. But a quadratic, well, if we put the turning point there, let's call that -1 and -3. So this would be x plus 1 squared minus 3 would be an example of that. But any quadratic works here. We've also got many to many. So many x values can give many y values. Well, let's look at this. This x value here of -3 can give that one or that one. So we get two different ones, and then similarly from the other way, here I can get that or that. So there's two x values that give the same y value, and there's two y values that give the same x value, hence many to many. This is not a big area that gets tested, but handy to know about. And whereas I'm talking about x and y, also think domain of a function mapping to the range of a function. Okay? I know in the book there's a couple of diagrams like that. Have a look at those. This is fairly simple for specialists, but we need to cover it. The next part that I want to do in this video is composite functions. Now, composite means putting two things together. Think of it that way. We're putting two things together, but the way that we put them together is really important. If I've got two functions here, then all of this notation means the same thing. My preference is for this notation, but some other people use other notation. It's fine. So long as the message comes across, it's okay. So what is this here actually telling me? This is saying that f of g of x. So what I'm really doing is I'm putting the x values go into g of x. I will get my answer out of g of x, and then those values that I get out, I've got to then put into f of x. Okay? So we start in g of x. Excuse me. We start with g of x, the thing on the inside, and then the answers from there we put into f of x. Okay? So think of it this way. If I took my x values, okay? Oh, I was going to do an example here. I'll do one in a minute. Think about this. If I take my x values, they are the domain of g of x, okay? Because that's the first function. I put them into g of x, and I would get the range of g of x. So that's the output of g of x. Input, output. Then what I'm going to do is I'm going to take the output of g of x, and that becomes my domain of f of x. And then of course here, this line here is the into f of x, and I will get out the range of f of x, or if you like, the range of f of g of x. Okay? Because of this whole process, this is really what I'm getting the range of. If you break it down to just this part, I'm getting the range, the range of f of x, but when I'm looking at the whole thing, I'm getting the range of f of g of x. Let's do an example there. Let's put this together and see what we get. So, if I'm doing f of g of x, that means that thing there has to go into there. Because f of g of x has to go into f of x. So that means that f of g of x is going to equal 2 x squared. This is now x. This is now the input value. Now I could, if I wanted to, expand that out. It's not really going to help me much. Now what should I look out for when I'm doing questions on this? Be careful of what you can put into here and therefore what you can get out. Okay? Now, what am I meaning there? Well, what happens if g of x equaled 1 over x? Well, I can put in any value I like, but if I let x equal 0, then g of x, it's undefined. I won't get anything out of that. So be careful about what this function is doing, as in what you can put in. So my domain of this function may be the set of real values, but I'm going to have to say, well, I can't let x equals 0 because it makes my function undefined. And if I've got the first one being undefined here, well, I can't bring that into the second one. So you might have to restrict the domain of your first function so that you can actually write this function. And then you've got to think, well, what values can I not get out of that function? And therefore, what values can I not put into the next function? And therefore, what values can I not get out here? Okay, so play it through this scenario. Okay, look at the first function, say, what can I do there? What can't I do? Okay, what effect does that have here? What effect here? What effect here? Okay, you've got to roll through the whole process. Okay, you'll make mistakes on this part, guaranteed. You'll look at an answer and go, but why? What's going on there? Trust me, these can get a little bit difficult. I'll do a video with a few examples when I get time. I want to rush through, get a lot of videos done today. So this will get you started. When you get to those trickier examples, have a crack, look at the answers, try again, give me an email, chris.simpson@cua.edu.au, throw the example in you want, and I'll do them for you. Catch you later, guys. Enjoy isolation.